Okay, guys. Now that I've got this displayed up here, we're going to do the introduction, excuse me, to the science and scientific method. This is seventh grade science. Um, so we're going to start out with this. You should know how or have heard of the scientific method. Maybe have went through the steps with the scientific method. If not, that's okay. Just let me know so I can kind of see where we're at to begin this. But right now, I just want you to kind of listen to the PowerPoint, jot down any notes if you would like to. You can rewatch this PowerPoint as many times as you want to, and you'll have a small assignment to go with this that you can do today. Alrighty. So, what is science? I know you all wrote to me about what you thought science is, but the science is the goal of science is to investigate and understand the natural world, to explain events in the natural world, and to use those explanations to make useful predictions for in the future. So without science, we would not be able to predict how maybe a strand of or a virus strand might react or might mutate. Um, Also, for physics, if we didn't have velocity and acceleration and these formulas to figure out how fast something is going, you would not be able to predict, a speed limit or how fast that car is going. Are they following the speed limit? So, science is found every day. It affects you every day, from the food, from toothpaste that you put in your mouth. Um, it is all science. Anything you can touch is science. Your body is science. Um, science has played a role somehow. So, like I said, science deals only with the natural world, not the superficial unicorn, um, dragon world, but our natural real world. Scientists collect and organize information in a careful, orderly way, looking for patterns and connections between events. So they're always studying something. They're always making new um, theories, new. Um, I'm trying to think of the word. I lost my train of thought. But always new discoveries, or even looking at the older discoveries, finding out that okay, what was back then is not what is now. If you take the discovery of an atom, the different models they have shown over the years have changed based on the technology they came up with to see the atoms or make out the atoms. So, scientists propose explanations that can be tested by examining evidence. So, everything they look at is tested, they have evidence. If they do not have evidence to back up their theory or to back up their hypothesis, it's not done. I know a long time ago this guy made a article about autism and it being through the vaccinations. He had no evidence to back it up, so no one really knows. So you have to have evidence and an explanation to and tests that prove your theory or disprove it, if that's what you're trying to do. For science is an organized way of using evidence to learn about the natural world. So, how is science done? Science begins with an observation. So, you had a question on who does science. Anybody can do science. My daughter, who is 5 years old, can do science because you make an observation. This is the process where you're gathering information about events or process in a careful, orderly way. Like maybe you notice something that's happening constantly every time. That's an observation. Data is the information gathered from making your observations. So maybe you notice when sugar is laid down in the ground, more ants come to it than salt, or so forth. That's data you've collected. That's an observation you have made. There are two types of data. There's quantitative data. Don't you, I'm going to tell you this, but we're not going to go more in depth with the quantitative and qualitative. You'll learn about that later on. But the quantitative data are the numbers and are obtained by counting or measuring. So they can actually, they're your numerical data, the quantitative. Qualitative data is descriptions or involving characteristics that cannot be counted. So that's more of your written data. So quantitative is your numbers and counting. Qualitative is your written data. So a hypothesis, that's the next. So you make an observation, you come up with some questions, you might do some research, and then you come up with a hypothesis. So a hypothesis is a scientific explanation for a set of observations. A hypothesis must be stated in a way that makes it testable. So, and we'll talk about how to state your hypothesis here in a little bit. But the hypothesis is just a possible answer to a question, and it must be thoroughly tested. So if your question that you come up with, does this A fertilizer work better than B fertilizer? Your hypothesis would be A allows the plant to grow 2 centimeters taller than B fertilizer. So that's your hypothesis that you could test out to either prove or disprove. The scientific method is a series of steps used by scientists to solve a problem or answer a question. And the steps of the scientific method is observation, asking a question, form a hypothesis, design a controlled experiment, and we'll talk about that in a minute, record and analyze results, and then draw your conclusion. A lot of scientists don't always follow them 1, 2, 3, 4, 5. So they don't have this listed up on their wall and saying, okay, I got to observe first. Oh, I got to form a hypothesis. Sometimes it might be a little bit skewed or a little bit out of order, but for the most part, you make observations with your eyes or your 5 senses, and then you form a hypothesis on something you might be interested in testing. So step 1 in observation, a problem or a question must first be identified. How much water can a root hair absorb? So the hair or the roots that look like hairs is what I'm saying. You've seen them, they're kind of like fine like your hair, but they're stringly out. So how much water can a root hair absorb? Why does a plant stem bend toward the light? So why does majority of the plants bend towards the light? What effect does temperature have on the heart rate? So does your temperature or your body temperature affect your heart rate? That's a question. That's an observation. Then step 2 is form a hypothesis. So it's a possible explanation to the question or problem. Something maybe you think that this is why this does this. It's simply a prediction and has not yet been proven or disproven. So it must be stated in a way that is testable. A statement is considered testable if evidence can be collected. So if I said a root hair absorbs 3 milliliters of water a day, that's testable because I can test that. But if I just said root hair absorbs a lot of water a day, that's not specific enough to be tested. So it can either, the evidence can either support it or it doesn't support it, either way. Step 3, designing a controlled experiment. And this is where a lot of people get confused. because they don't quite understand controlled experiments. So if you have questions, email them to me or private message me, whatever you want to do, because I'm going to try to explain this the best way, but some people get kind of confused or don't really understand this part. But the factors in an experiment, so you're setting your experiment up. You've got your plants, you've got your water, you've got your cups, or maybe the pots that they go in. You've got your seeds, you've got sunlight, you've got everything that you need to fully go through with this experiment. So the factors that are in this experiment that can be changed, like the cups, the soil, the types of seed, the amount of water, those are your variables. Temperature, like this said, the amount of light present, you can control that to where you put the plant. That is the variables. A controlled experiment works with one variable at a time. So if several variables were changed at the same time, the scientists would not know which variable was responsible for the results. So if I did like 20 different cups and 20 different types of seeds, and not the same, and I put 3 different fertilizers in there, I'm not going to get reliable results that yes, A fertilizer works better than B fertilizer. So a controlled experiment only changes one. So that would mean I would get the same cup for maybe 5 plants, the same seed, the same type of soil, the same type of, or same amount of sunlight, the same amount of water at the same time each day. And the only thing that would be different would be the types of or the 2 types of fertilizer I would use. So maybe half of them I would use A fertilizer, half of them I would use B fertilizer. And that way nothing is different except the fertilizer. So that way I know I'm testing just how well the fertilizer works. So I might have gotten ahead of myself, but in a control experiment, only one variable is changed at a time. All other variables should be unchanged or controlled. An experiment is based on the comparison between a control group with an experimental group. Now, the control group would be the things that you did not change, that you kept the same, like the size of the cups, the same soil, the same type of seed, the same amount of water, the same amount of sunlight. The experimental group would be fertilizer A and fertilizer B, because that's the difference. Those are the 2 different fertilizers. So A, these 2 groups are identical except for one factor. The control group serves as the comparison. It is the same as the experiment group, except that one variable that is being tested is removed. And the experimental group shows the effect of the variable that is being tested. That would be the fertilizer. So let's look at examples real quick. So in order to test the effectiveness of a new vaccine, 50 volunteers are selected and divided into 2 groups. One group will be the control group. The other group will be the experimental group. So both groups are given a pill or a medicine to take that is identical in size, shape, color, texture. So the control group that they're controlling, because they want to look at the effectiveness of a new vaccine, is even though the volunteers are given the identical looking medicine, the control group will not actually receive the vaccine or the medicine. They will receive like a placebo, a copy, but it might just be sugar. But they don't know that because it looks exactly like the other medicine. The experimental group is the one that we're trying to see if the vaccine actually works. So they will actually get the medicine that has the vaccine in it. What variables are kept constant? So the color and the amount, the size, the shape of the medicine or the vaccine is all kept constant. What variable is being changed? Whether or not the medicine contains the vaccine. So group A might have the medicine that is just sugar, but it looks like the vaccine. Group B might be the group that gets the actual vaccine or the medicine. So that group will be watched to see if there's any effects compared to the group that's not getting the vaccine but getting the sugar pill. So there are two variables in an experiment, and we'll go more into depth next week on independent and dependent variables. But the independent variable is the variable that is deliberately changed by the scientist. The dependent variable is the one observed during the experiment. So the dependent variable is the data we collect during the experiment. This data is collected as a result of the changing the independent variable. So in the medicine one, the independent variable would be whether they get the sugar pill or the actual vaccination or vaccine pill. The dependent variable would be the chart or the data collected on what the vaccine was doing to the people. If it was helping, if it was changing what they needed to do, that would be the dependent variable. So it's changing on if they had the actual vaccine or if they had just the sugar pill. So in the above example, we're going to look at this. Independent variable is the addition of the vaccine to the medicine that were given to the volunteers. So the medicine or the sugar pill. So the dependent variable is the observed health of the people receiving the medicine. And then if it's not making a difference or if they're the same as the ones that didn't get it. Recording and analyzing results. The data that has been collected must be organized and analyzed to determine whether it is reliable. So when they collect the data, they have got to come up with a way that it's organized, it flows, and it determines whether, this was a good experiment, there was no flaws or exceptions that hindered the results, or we got to go back and look at the test and see what we can control better. So does the data support or not support the hypothesis is when you come after you get it organized. So did it support what I thought or did it not? So the evidence from the experiment is used to determine if the hypothesis is supported or not. Experiments must be repeated over and over. The scientists do not just do one experiment and say, okay, there's my theory. It's proven or it's not proven. They conduct experiments over and over and over. When it's repeated, the results should always be around the same before it's validated that, yes, it supported my hypothesis, or no, it did not support my hypothesis. So doing one experiment to prove something is not very reliable. They work constantly doing multiple experiments and trying to get the same results to prove that, yes, their hypothesis was correct, or no, it's not correct. So forming a theory may be formed after the hypothesis has been tested many times and is supported by much evidence. So theory, a broad and comprehensive statement of what is thought to be true. A theory is supported by considerable evidence. So just like energy is proven, we know that there's different forms of energy. We know that there's atoms that make up everything. These atoms form the elements on the periodic table. These have been tested over and over and over and have been proven. So we are going to look at a practice problem. You want to determine the effect of a certain fertilizer on the growth of orchids grown in a greenhouse. Materials are available to you. A greenhouse, 100 orchid plants, water, fertilizer, and soil. You want to know if the orchids will grow best with a weak concentration of fertilizer a medium concentration of fertilizer, or a high concentration of fertilizer. How will you design an experiment to test different concentrations of this fertilizer? So we would state our hypothesis. A possible answer to the hypothesis, is that I predict that orchids will grow best with a medium concentration of fertilizer. That's what I want to test out. So when I set up my controlled experiment, here's one possible way. The 100 plants will be divided into 4 groups as follows. So 25 plants apiece. 25 will receive plain water. Group 2, 25 plants will receive a weak concentration of fertilizer. Group 3, 25 plants will receive a medium concentration of fertilizer. And group 4, 25 plants will receive a high concentration of fertilizer. You always have this controlled group, group 1, that does not receive any fertilizer to see if the fertilizer even makes a difference. So the plants will be watered daily over a period of a month. The plants will be measured to see which ones grew the tallest. So control group. What's the control group in the experiment? The control group consists of the 25 plants that are just receiving plain water. The experimental group is the other 75 plants that are receiving different concentrations of fertilizer. So the low, medium, and high levels of concentration in fertilizer are your experimental groups. In a controlled experiment, all variables must be kept constant, except the one variable that is being changed. So what variables must be kept constant? And when I say constant, the same in this experiment. So all plants must receive the same amount of fluid each day. All plants are grown in pots of equal size. All plants are grown at the same temperature. All plants receive the same amount of sunlight. And these constants in an experiment that are kept the same, so this doesn't affect how tall or if your plant even grows. So what variable is being changed in this experiment is the amount of fertilizer received by each group. After 1 month of measuring the orchids, the following data is obtained. Group 1 grew to an average height of 15 centimeters. Group 2, which is the weak, grew to an average of 35 centimeters. Group 3 grew to an average height of 28 centimeters, and they had the medium concentration. And Group 4 had the high concentration and grew to an average of height of 10 centimeters. If you know about fertilizer, you know that it can burn a plant up if there's too much. So that's probably why the high concentration did not grow as tall as the rest. But is your hypothesis supported or not by these results? We said that the medium fertilizer would grow the tallest. The results do not support this. The results do not support our hypothesis at all, because if you look, the weak concentration grew taller than any of the rest. So the conclusion based on these results is orchids grow best with a weak concentration of fertilizer. At a medium to high concentration, plant growth is inhibited, or they don't grow very tall. Why is it important to have a large sample size in any experiment? So sample size would, it is important to have a large one to get a true picture. So if I only had 10 plants in this experiment, there might have been something wrong with the plants to begin with. So you want to have a large group to make sure you're getting more accurate results. So it's important to test a large sample in order to get a true picture of the results of the experiment. If the size sample is too small, an inaccurate conclusion may be reached. Results obtained by testing a large number of individuals would be much more accurate if only a few individuals had been tested. So, Testing a large group gives that error for the ones that weren't going to make it anyways, if we're talking about plants. Why is it important to repeat the experiment many times? Experiments should be repeated to see if the same results obtained each time. This gives validated, oh, I can't talk. It validates your results. What is the importance of the control? The control shows what will happen when the experimental factor is omitted. That means taken away. Without the control group, there would be no basis for comparison, and you would not know how the experimental factor affected the results. So in our plant experiment, if we did not have that group that did not get the fertilizer, we wouldn't know if the fertilizer even made a big impact or not. So if we had a group that did not receive the fertilizer, just received plain water, we can compare the two based on if they got the fertilizer or not. How is a theory different than a hypothesis? So a hypothesis is an educated guess. I'm sure you've heard that a million times. That is testable through observations and experimentations. A theory is a broad statement of what is believed to be true based on how many experiments, considerable amounts of data. So hypothesis is your educated guess. A theory has data to back it up. So why is it so important that a scientist accurately describe the procedure used in the experiment? It allows other scientists to repeat the experiment and verify the results. So everything scientists do, they write it down step by step by step. Whether they move a jar like 2 inches, they write it down so that another scientist can come up and do the experiment just to test their hypothesis, or maybe even to prove that they were wrong. They write it down so they can follow the exact steps so that nothing is skewed or left out. What is the difference between the independent and dependent variables in an experiment? Like I said, we'll go more into depth with the independent and dependent variables next week, but independent variables is a variable that is deliberately changed by the scientist. So that would have been the fertilizer, the types of fertilizer. Or not the types, but the concentrations, low or none, low, medium, high. The dependent variable is the one that you observe during the experiment. So that would be how much growth those plants got with each fertilizer or no fertilizer. The dependent variable is the data we collect during the experiment. So dependent is collected, independent is what we change as a scientist in our experiment. In a controlled experiment, why must all the variables except one be kept constant through an experiment? If several variables were changed at the same time, the scientist would not know which variable was responsible for the observation results. So if I didn't keep the different size pots for the plants the same, who would know if the plant grew better because it was in a bigger pot or a smaller pot? So that's why a lot of the variables have to be kept the same so it doesn't change your results. This is the end of the PowerPoint and the lecture. You will have a small assignment to do today on the scientific method, and then Tuesday you will have the last station labs to do. We're going to try those out online, and if you have any trouble, contact me. But hopefully that'll run smoothly because it's a form that you fill out online while you do the stations on another screen, and then you just submit it electronically. And Wednesdays will be IXL. I will put up the topics or the skills I want you to work on each week, and you just click on it and go, as long as you've already signed into Clever. Thursdays will be another assignment on the scientific method, and then Fridays will be a short quiz over the scientific method to see if I need to go back and hit any other things before we move on. Because the scientific method, we're not going to stay on very long because you should have heard about this in other science classes. But if you have any questions, please contact me, email me, or come to our Google Meets each week, Monday, Tuesday, Thursday, and Fridays from 12 to 1. And hope you have a good day. Thank you.